So following on from the previous video, we were trying to vary x here. We were trying to vary this length here, and it turns out that as we vary this length here, the length of the ladder is given by this here. Okay, so when you get to this stage here, you in effect have a graph of L, the length of the ladder, versus x here. Okay, it makes no sense for x to be less than 7. Okay, so when you get to this stage here, we now need to find out. So in a way, we've got a graph, the graph of L versus x here. We want to find out where the gradient is 0. So we want to find out this point. But don't just blindly jump into there and find and try and differentiate it. We need a sense of what's going on, because by you just blindly jumping in and finding out when the derivative will be 0, when you do find it, it could give you a maximum or it could give you a minimum. You need a sense of what's going on here, because by you just finding out when the gradient, so if you differentiate this and then set the dl by dx to be 0, it could give you the minimum or it could give you a maximum. You need a sense of what's going on around here. Okay, so at the moment we are currently at this stage here. So we've got a graph of L versus x. This thing here breaks down when x is dead on 7. It breaks down. So something weird happens at x equals 7. And now we need a sense of what's going on around this region here. Okay, because by you finding out when the derivative is 0, it could give you a minimum, or it could give you a maximum. We need a sense of what's going on. So if you look at this bit here, it breaks down when you put 7 into this thing here. This thing here breaks down. So select a number just to the right of the 7. So put 7.00000001 in here. So when you put this number into here, it will be, this thing here will be very, 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 very small. A positive very, very small. Now 21 divided by a very, very, very small would mean that this whole thing here would be very, very, very big. Okay, I know you have to think about this. Okay, you have to think about it. Hang on. L x 7 here. When you put a number just to the right of the number 7, this thing here would be very, very, very small, positively small. And then this whole thing here, 21 divided by something very, very small, would be very, 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 very. When you get 21 divided by something very, very small, the overall thing here will be very, very big. And then very, very big, add a number 3, it will still remain very, very big. You square it, it will be even bigger. A very, very big squared would be very, very big. This thing, add this thing, don't really care about this. But this is already very, very big here. So when you look at the graph of the square root of x, it's something like this. You see, when x is very, very big, this thing here is also, well, this thing here will be very, very big. Okay, so this thing here will be, it would do something like this. Okay, so hang on. So just to the right of the 7, just to the right of the 7, this whole thing here would be very, very big. Okay, would be very, very big. And then now let's consider what happens when x is very, very big. So if you put a very, very big number into here, let's say 9,99999, put a very, very big number into here, then this thing here will be very, very, very big. Okay, because very, very big, take away the number 7, will still be very, very big. And 21 divided by very, very, very big, this thing here will be very, very small. Okay, this thing here will be very, very small, plus 3, it will be very, very small. So this thing here will be very, very small. But then when you look at this, if you remember, we are putting a very, very big number into here. This thing here will be very, very small. We can pretty much forget about this. But the point is that this thing here will be very, very big. So when you look at this here, you've got a graph of L versus x. with the 7 being here. Just to the right of 7, you're going to get something very, very big. And then just to, well, as x tends to, as x gets very, very big, then this thing here is also very, very big. Okay, so we're going to, the point is here, the point is that when you differentiate this, we can now deduce that it will give us a minimum. Okay, it will give us the minimum length of the ladder. Okay, so in the next video we're going to try and differentiate this. So but something to bear in mind, don't just blindly differentiate it. You need a sense of what's going on. You need to know the surrounding here. 7 and x being heading towards infinity. We've established that it's going to be something like this. So we know it's going to give us the shortest ladder as opposed to the longest ladder. Okay, I will continue in the next video.